Welcome to the final video of the chemical quantity section, and I do promise that this is the final video. We're going to continue working with the mole, and this is part 3. Remember, the last one was an interlude, where we're going to relate mole and molecular weight. In general, moles times the number of grams any 1 mole weighs is the mass of everything you have. Doesn't matter if you're dealing with Legos, atoms, stars, this holds true. But in chemistry, we're very much concerned with elements and compounds, not so much with Legos and cats and things like that. Now remember, in chemistry, the molecular weight, which sometimes is called the formula weight or the elemental weight, depending upon the conditions, but we're going to call it molecular weight, is given in grams per mole. This means the equation here can be rewritten as follows. Moles times molecular weight equals grams. This is most definitely index card material. You'll be using this the rest of the year. Now notice this is an equation with 3 variables, so if you know any 2 of the variables, you can calculate the third, and the best thing I can think of is just dive right in and start solving problems. So let's assume that you have 3.45 moles of xenon, and you want to know how many grams you have. Well, you pull out your equation, because this is the one that relates moles to grams. You go to the periodic table, you find the molecular weight of xenon, it's 131.29 grams. Oh, by the way, when doing molecular weights, carry it out to 2 decimal places, except for hydrogen and helium, where you'll go to 4 significant places. So now we know moles, we know molecular weight. Plug the values in, hit the calculator buttons, and when you convert to correct significant figures, 3.45 moles of xenon happens to weigh 453 grams. Well, for an element, that's easy. You just read off the periodic table. What do you do for a compound? Which means I have an example. You have this many moles of calcium chloride. How many grams do you have? And you do it the same way. You start with your basic equation that relates moles and grams, and we can figure out what the molecular weight is. So we look at calcium chloride, where we have 1 calcium, 2 chlorines, multiply each of the atoms by its atomic mass, and that gives you the contribution of each element. Add up those contributions, and there is the formula weight or molecular weight for calcium chloride. 110.98 grams per mole. So go back to our original problem, look at our equation. We now know moles and molecular weight, so we can plug those into the equation. When you hit the equal button on your calculator, you're going to get this number. And so when you put into correct significant figures, you realize that 2.69 times 10 to the minus 3 moles of calcium chloride weighs 2.99 grams. All right, let's change things around a little bit. This time you're going to be given grams and asked to figure out the moles. Well, as soon as you know what a chemical is, you can calculate the molecular weight. You've got the grams, so this equation is going to work for you. So this equation will work for you. So now you take a look at magnesium acetate. 1 magnesium, 4 carbons, 6 hydrogens, 4 oxygens. Here are the contributions of each element to the whole. And the whole is the sum of the parts. So when you add it all up, you get a molecular weight in correct significant figures of 142.40 grams per mole. So back to the original problem. This is the equation we want to use, but now we know molecular weight in grams, so we can rearrange the equation to look like this. Plug in what we know, hit the calculator buttons, and convert it to correct significant figures. Now know we have 0.3409 moles. All right, you got some compound. You don't know what it is, but you have told that 0.02250 moles has a mass of 1.037 grams. What's the molecular weight of this compound? We can't go to the periodic table to figure out what the molecular weight is because we don't know the molecular formula. But we do have this equation, and here we happen to know the moles and the grams, so it can be arranged to molecular weight equals grams divided by moles. Plug the values that we have in. 1.037 grams is equal to 0.02250 moles. Once again, use your handy-dandy calculator, and when you convert to significant figures, you realize the molecular weight of compound X is 46.09 grams per moles. So now for elements and compounds, You're sometimes going to want to go from grams to particles or particles to grams. Now we can go from moles to grams, and hopefully remember that we can go from moles to particles. This will be done in a two-step conversion. So you need to remember that you never, ever put molecular weight or grams into the same equation as 6.02 times 10 to the 23rd. Never, ever. So you can go from gram to moles and moles to particles. Particles to moles to grams. You cannot go from total number of particles to grams in one move. So for example, you got a cup of water that weighs 487 grams. How many molecules? Remember, never ever put molecular weight or grams into the same equation as 6.02 times 10 to the 23rd. So you want to go from grams to moles. We want to start with this equation, but we want to calculate moles, so we rearrange it to look like this. The molecular weight of water is 18.02 grams per mole, so we can take the 487 and divide it by that, and we get 27 moles of water. Now we're going to go from moles to number, so we're going to use this equation, plug in what we know, hit the calculator button, and you get 1.63 times 10 to the 25th molecules. So the cup of water containing 487 grams has this many molecules of water. Last example, sodium chloride is needed by your body, and it's recommended that you're taking no more than 5.97 times 10 to the 22 formula units. Given the fact that you can't see the formula units, how are you going to figure out how much you're going to take? Well, we can convert. But remember, never ever put molecular weight or grams into the same equation as 6.02 times 10 to the 23rd. So we're going to go from formula units to moles. We start with this equation, but once again we want to find moles. So we're going to rearrange it to look like this, plug in what we know, and we get this many moles. Now we're going to go from moles to grams. So we're going to use this equation. We plug in what we know, and we can easily calculate the molecular weight of sodium chloride. The moles we just calculated times the molecular weight, or the formula weight. This is what shows up on the calculator. So we would say that the 5.97 times 10 to the 22 formula units of sodium chloride weighs 5.80 grams. So to review, we have moles, we have grams, we have the number of things. To go from moles to grams, you're going to multiply your moles by the molecular weight. To go from grams to moles, you're going to divide the grams by the molecular weight. To go from moles to the number of things, you're going to multiply by 6.02 times 10 to the 23rd. To go from the number of things to moles, you're going to divide the number of things by 6.02 times 10 to the 23rd. But there is one final thing. Turns out that 6.02 times 10 to the 23rd is frequently called Avogadro's number, or Avogadro's constant. This is named after Amedeo Avogadro, who lived from 1776 to 1856. He was a lawyer and a physicist and did an awful lot of work with gases, and he's the person who realized, or first came up with the idea, that the number of gas particles was directly related to the atomic mass. And so when they finally calculated the value of 1 mole, they named it in honor of him, and so it's called Avogadro's number, though he never had any idea of what that value was. So that completes Section 9. Section 10 will be coming forth soon, and this will deal with manipulating formulas, percent compositions, and using molar relationships.